Hello everybody and welcome to another mystery box function challenge. In the purple box there is some mystery math and your challenge is to figure out what it is. You can use the link in the description if you want to try this out on your own, and when you've got an idea come on back and see if we get the same thing. All right, I'm going to start with a 0. Okay, that gives us 1/3. How about a 1? It's 0.25. How about a 2? 0.2. So it's a curve and we're approaching that x-axis a little more shallowly every time. Let's try a 3. Oh, and that's not a number. So not a number we often get when we see the square roots of negative numbers, but we saw this just a couple of days ago with a removable discontinuity. So is this going to be a rational function with one of those? Let's keep that in mind. In fact, let's go over to -3 and see what happens there. Aha, and there we're getting that infinity error. So I'm definitely thinking rational function now. Let's fill in the graph a little bit. Let's continue on the right with 4. Let's go out to 9. Okay, and then let's put in some negative numbers. So -1, -2. I'm going to put in -2.5. Yeah, and then let's put in -3.5. Just want to see what it's doing around that point I think is an asymptote. And then let's go on to -4. And maybe -8. Okay. So in general here, what I'm seeing is an arm here and an arm here. And we should just check a little closer to 3 to make sure it's not doing something funny, because that's an undefined point of the function at 3. So maybe it's an asymptote. So let's look at 2.5. Let's look at 3.5. Yeah, and it does appear to just be a smooth, continuous curve there. So I think we have a rational function with an asymptote here at -3 and something funky going on at 3, which I think is going to be a hole in the graph, a removable discontinuity. So how would you get that? Well, just looking at this graph without that hole, I would think of, let's see, to get -3, you'd have on the bottom x plus 3. And so this could be as simple as 1 over x plus 3. And let's just see if that kind of works with these points. So yeah, if we put in a 0, we're definitely getting 1/3. If we put in a 1, we're getting 1/4. If we put in a -1, we're getting 1/2. And this got a little off kilter here, but that is working for all of those. If this point is not defined, though, it's because we have a quadratic on the bottom, and this factor was allowed to, the other factor was allowed to disappear to factor out. So what if we had a difference of squares there? So we had x squared minus 9 on the bottom and an x minus 3 on the top. Okay, so let me explain why I think that's what it might be. If you factor this difference of squares on the bottom, you're going to have x plus 3 times x minus 3. These go away, and you get 1 over x plus 3. And 1 over x plus 3 is what seems to work with all of these points, except, of course, it doesn't work with 3. So if we put in a 3 here, we should get 1/9. We get not a number. And so that doesn't work. So I think this is what's going on here. Let's just pick one more point and see what's going on. Let's put in a -2. And let's do it in both of these. Make sure we're getting the same thing. So 1 over -2 plus 3. 1 over -2 plus 3. That's going to be 1 over 1, or just 1. Okay, and that's what we're getting for -2. We're getting 1. These are a little out of alignment, but that's how it worked there. And if we do the same thing here in the x minus 3 over x squared minus 9, which is what I think it is, so there'd be a -2 minus 3 over -2 squared minus 9. That's going to be a -5 on top and a 4 minus 9, a -5 on the bottom. -5 over -5 is going to be a +1, and that all works out. So I think we got it. Let's go ahead and take a look. Yeah, x minus 3 over x squared minus 9, and we can graph that as well. Looks like your typical rational functions, just got that 1 point that doesn't exist in the graph. Well, how did that go for you? Did you find the removable discontinuity? Let me know. Thanks, everybody.